Hi, this is our project of WordJet, and we are going to make this project based in the theory of Daniel Bernoulli. Daniel Bernoulli was a Swedish mathematician and physicist, and he is particularly remembered for his application of mathematics to mechanics, especially to fluid mechanics. In fluid dynamics, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in a pressure or a decrease in the fluid's potential energy.
The overall objective of our project is to determine experimentally and computationally the range of the water exiting the hole versus the time is if a large cylinder filled with water.
The procedure, we're going to use a cylindrical tube and fill it with water, and using the data obtained, we are going to create a computer program using Eclipse Java that is going to give us the range in function of time.
The setting for this project was here in our school at Tecnológico de Monterrey and Drill section of the third floor of the library. The theory and data we're going to use is for these three formulas. The first one is for the volume that exits the area of the hole. So we have the area and the velocity is equal to the second area then times the second velocity. Then we have Bernoulli's equation that uses pressure and potential energy and kinetic energy, and it relates it to the second one, so we're going to use that. And then we have our kinematics equation. We have the velocity equals the initial velocity plus the acceleration times the time.
Well, here's the program that is made in Eclipse. And the language used for the programming was Java. As we can see, and here are the variables of velocity, time, the height that we got, the gravity, the distance, and all the variables that we need for this project. Forget all the data. We use the formulas told in theory and data. We use a for buckle where I is considered the time that transcurred during the here is the data used during the experiment. I'm sorry because of the code of the video. It didn't record it all, and well, here I am again. We tried to put all the data together, but for a reason, Java didn't allow us that, so we did it separated. As we can see, in AUX number 1, we use all the content of the first formula, 2 multiplied by gravity multiplied by the height of the tube, and all get the square of the result of AUX. And then to get the velocity, and then in AUX2 we made this formula where we rest the height of the tube, well, all the height of the tube minus the top to the hole of the tube. all that multiplied by 2 and then divided by gravity, and then we got the square of aux2, that is all the formula told, and to get the time. Then we use the typical formula to get the distance, that is velocity multiplied by time. Sorry about the sound, that is the sound of the background. So we run the program, and well, there it is. We got the height of the water, of the water dropped out, and the time we got from the video recorded. And as we can see, the distance, it depends on the time, and as long as the time passes, less as the distance is. For the recommendations, we recommend you to have something to plug the hole of the cylinder, because that was a bit complicated for us without having anything.
From this we can conclude that the range is inversely proportional to the time, because we can observe that the range is greater at the beginning when there is more water in the cylinder, and as time goes by the speed of the water exiting is slower, so the range reaches a lower distance.